Hi everyone. Hey guys, am I audible? Hey everyone. Today we are going. This is the third session, right, of dynamic programming. So we are going to continue that we have done in the last two sessions. So let's start. Okay, I'm a little bit late. I know that. Actually, something came up. So yeah. So let's start. So yes. So hello everyone. My name is Rahul Singla. I am SD1 at Innovator. I was ex-mentor and SD at Geeks for Geeks. I mentored a lot of students from major IITs and NITs. I cracked companies like Grofers and Swiggy. And the subjects that I am taking here are Core Java, Oops in Java, and DSA in Java. Okay, and you can use my code rsingla10 and get a free Relevel sample test paper. Okay, let me tell you about Relevel. So many a time students miss out on great opportunities due to multiple reasons. What are those reasons? They didn't have a better degree or have a poor network, right? Your resume doesn't stand out of with those 100 applying for the same startup. You have applied for 50-60 companies but haven't been called for even a single interview. These are the problems that we all face, right? And to overcome these problems, Unacademy has introduced Relevel, India's first test hiring platform by Unacademy, which is helping job seekers find their dream jobs. Now you can get a job basis only on your skills and talent. You need not to depend upon any degree or other people in your network. Okay. And what are the benefits of participating in Relevel tests? So over 50 plus companies including top startups and unicorns are there. 1,000 plus job positions across business development, front-end development and back-end development are there. You can attempt this test for free. This is a free test. Finish your test in a single day of your choice and get your Relevel score within a week. This is the best thing, right? And with Relevel, you are in a unique position to invite interest from the companies instead of hunting for opportunities on your own. Okay, and how to register on Relevel? It is very easy. Get your job, like you can get the job in 15 days only. So just go and click on get hired. Like there's a link in the description box. Then you have to click on get hired. Then you have to choose a test. Business development, front end development, back end development, whichever field you are interested in, you have to choose a test. Once you choose a test, then you have to book a slot. And whichever date you want to give the test, that is the slot you have to book. Okay, and slots are very limited, so just go and book them as soon as possible. After that, you can mention my promo code here rsingla10 while filling the admit card, so that you can get a free sample test paper. Okay, sorry, and you can use my promo code. Okay, that's done. So after the promo code mentioned, you will get the sample test paper in this practice session. Okay, so that will be very helpful before the main test. So just go and register for Relevel today. So also join our Telegram channel if you haven't yet. So this is the link for the Telegram channel, so just do that. And also just go like, share and subscribe. This is very important, so that all your friends can also learn from all the mentors, right? And dynamic programming 3. So these are the two questions that I have decided to do today, that longest common subsequence and edit distance. Okay, so this is what we are going to do today. So let me start in a bit. Let's wait for people to join. How to find this particular question is based on DP. How to find this particular question is based on DP. Okay, so if you have attended the previous class, you will get it. That previous two classes I have told like where to use DP, where not to use DP. So you can refer that, or I'll give a small example. So basically, what we do is, let me just open it. Okay, so let's start. Let me just open it. So wherever there is like sub problems, overlapping sub problems, there you have to use DP. Okay, other than that you don't have to use DP. Only when there are overlapping sub problems, then only you can use DP. Okay, that is the case. So in these questions as well that we are going to do, these are the questions that actually are very famous, right? We know that DP will be used here, but you can see as well, okay, there will be overlapping sub problems, and you can do it with the help of recursion as well. Okay, that is the case. So let's start with the first question, right? So which is longest common subsequence. Longest, let's first of all search it on net so that we know which type of question is this and everything. So longest common subsequence, right? Here we have it. You can see longest common subsequence. So this is the question that we are going to do. So where is that? Is practice here. So let's see here. Okay, so this is find the longest common subsequence of string A, which is a substring of string B. So what we have to do actually is, we have two strings, one string and second string. So you have to find the common subsequence, right? Common subsequence that is the longest in both of them. Okay, so common subsequence means, let's say here we have A and here we have A, right? It should be in the order, but they can be in between as well. Okay, what does that mean? That if we have A here, we have A here. Okay, then is there any B? Yes, B is there. Then C, yes, C is there. D, yes, D is there. So it should be in the order A, B, C, D, right? So here you can see as an example, longest common subsequence, because ACD is the longest. ACD, okay. Okay, so that's the problem, that we have C in between, right? So it can be only ACD. So they are talking about subsequence X is a substring of this, and all the letter strings are uppercase. That is okay. So we have ABCD and BACD. Okay, so ACD is the longest common subsequence that we can have. But if it is a subsequence, okay, just a second. I have to share the link. Yeah, let's start. I'm just putting a message on Telegram channel because I have started a little late. Okay, so what we actually have to do is, let me show you here. So let's say we have A, B, C, D, right? And we have, let's say, A, D, B, C, X, Y. Okay, so let's say these are the two examples that we can take. This is str1 and this is str2, right? So what we have to actually do is, we have to find the longest common subsequence. Longest common subsequence that we can find in both of the strings, right? So in that case, what we have to do is, we have to find, let's say here we have A, that is A. We have got A, right? Now in this order only, so here we have B, right? Here we have B. So here we have C, here we have C, right? So longest common subsequence in these two strings can be ABC, Okay, this is the question that we have to do, that we have two strings and we have to find the longest common subsequence. I think this is a different question that I have opened here. Substring subsequence problem, longest subsequence of X of a string A, which is a substring. Okay, here we are talking about a substring. No, we have to talk about a subsequence, right? This is a different question that we actually have to take, right? So let me open it in another tab so we know. So longest common subsequence, if this is the right one. sorry. So let's open it. Okay, so given two strings text1 and text2, return the length of their, yes, this is the question that I was talking about. So we have to find, we are given with two strings, a text1 and text2. Okay, we have to return the length of the longest common subsequence. If there is no common subsequence, return 0. Okay, a subsequence of a string is a new string generated from the original string with some characters can be none, deleted without changing the relative order of the remaining characters. So let me make you understand this. So here we have ACE, right, which is a subsequence of ABCD. Okay, so here you can say ACE, which is there in ACE. The order is same, but some characters can be omitted. Okay, so subsequence, we already know there are a lot of subsequences that we have seen. We have seen a question on this as well, that how we can find the number of subsequences, or you can say we printed the subsequences. So let me first explain what is subsequence. So for ABC, subsequences are AB, AC, BC, like any order, but the order can be same. Order should be relative, like if A is before, then C should be after, but any order, like we can omit any character as well. So here we can omit B, so it can be AC, it can be AB, we can omit C. Okay, it will be ABC, it can be A only, it can be B only, it can be C only, it can be empty string as well. Okay, so these are the subsequences, right? And we have to find the longest common subsequence in two strings. Okay, so let me just take this example, ABCDE and ACE. Okay, ABCDE, ABCDE and ACE. So this is, let's say, str1 and this is str2. These are the two strings I have. Now we have to find the common in them. We have to find the common in them. So here we have A, here we have A. Okay, that is good. So here we have C, here we have C, here we have E, here we have E. So answer will be 3. We have a longest common subsequence will be 3, right? So now the thing is how we find it. Like now here we can see directly in order, but here in this string as well, it can be like this. It can be like A, F, G, H, C, E. Let's say this is the string that we are following. Okay, so in this string as well, what will happen is now it will be difficult to actually find out. Like, okay, this is A, then it's okay, but how to proceed further? How to proceed further? We have to go for each path. We don't know if B and F will be equal or not. We don't know if B and G will be equal or not. We don't know C and F are equal or not. Okay, so we cannot go on each of the characters and find out that if there is any string, like if we can find all the substrings and then we can find, okay, which is the longest one. That will be very difficult, right? So in this case, what we have to do is we will do it with the help of recursion. Okay, we will do it with the help of recursion, right? Because we can break it in sorry, we can break it in a small small problems of the same type, and then we can solve it. Okay, so we can use recursion in this. How we are going to do that? So let's say we take a small example. Let's say AB and CA. Okay, let's say this is the example that we have. This is the small one, right? What we have to do in this is, so let's see the first character only. Let's focus on the first character only. Here we have A, here we have C. Okay, so what we want is, we want the common characters, right? Then we can only say that this is a common subsequence. So here A and C are not equal. A and C are not equal. So what is the best case? What is the best case? What we can do? So what we can do is either we compare this whole string with this string, like the remaining string of the second string, right? One option is this, or we try to take we try to move out this A, okay, and we take this string, this part of the string, and this whole string. Okay, these are the two options we have. That either we don't take this C, okay, we don't take this C, and we try to find out the common subsequence in this string and this string. Okay, second option is that we don't take this A, we start from B and we find the common subsequence in this part. Okay, and whichever will give me the maximum, like maximum number, like maximum subsequence, length of the subsequence should be maximum, so that will be my answer. Okay, if they are not equal, so what I'm trying to say is, let's say AB and CA. Okay, now A and C are not equal. Either I try to find this A in this rest of the string. Okay, so this A and A equal, so the length will be 1. Okay, common length will be 1. There is nothing else after it. Okay, or I try to find this C in this part of the string. Okay, I try to find this C because A and C are not equal, right? I try to find this A in this part of the string because they are not equal, and then what I'm trying to do is I'm trying to find this C in this part of the string. Okay, so this part of the string means that I am trying to find C and B are not equal. Okay, so and there is nothing after it. So the answer will be 0. The answer will be 0. Why? Because this C is we cannot find in this part of the string. Okay, so what is the maximum of them? What is the maximum that? It will be 1. So the answer, if they are not equal, will be 1. Okay, if they are not equal, the answer will be 1. Right? So this is the case. This is the case. So this is what we have to do, AB and CA. So in this case, now we have two cases actually. We have two cases. Let's start with that. Okay. So let's say if the first characters are equal, if the first two characters, its first character and its first character are equal, then it is for sure we want to include it into our answer, right? Because we want to find the common subsequence, right? If they both are equal, then we want to include it in our answer. So our answer will be 1, like for them, A and A, they are equal, so 1 plus whatever will be the common subsequence in this of the strings, this part of the string. Okay, so it will be, let's say the function name is if, let's say str1 of 0 equal to str2 of 0. Okay, so in that case what will happen? In this case what will happen? It will be 1 plus maximum of, sorry, not maximum, 1 plus this part of the string, like this part will be, let's say this is I, this is j. Okay, so it will be I plus 1 common of I plus 1 and j plus 1, common of I plus 1 and j plus 1. It will be like that. Okay, so this is the case. So it will be common of 1 plus I plus 1 and j plus 1, common of this part, right? So this is the case. I hope this is clear. Let's see. Yes, I hope this is clear, that we will take 1 plus I plus 1 part of the string, like this part of the string starting from I plus 1, and this part of the string starting from j plus 1, right? So this will be the answer. Okay, second thing can be if they are not equal. So let's say we take this case where they are not equal, right? So if I and j are not equal, str of I, let's say I is here and j is here, I and j, if they are equal, then we have to take this part. Okay, if they are not equal, so str1 of I is not equal to str2 of j. If they are not equal, then what we have to do? This is I and this is j. So in this case, as we have already discussed, that we have to take the maximum, like either this will be the answer, that answer 1 in this case can be, we take this part of the string and this whole string. Okay, that means from I plus 1 and j, okay, this part of the string common in this part of the string. Okay, or answer 2 can be common in this whole string and this part of the string. Okay, because if they are not equal, here they are equal, let's say this would have been C. So in this case A and C are not equal, so either we have to find this string, like this whole string, in the remaining string of this part we will remove A, this can be one answer, or either we remove C and we try to find this whole string in this part. Okay, so that will be I or j plus 1, okay, and we have to take the maximum of both of them, maximum of answer 1 and answer 2. Okay, maximum of answer 1 and answer 2. Okay, so this is what we have to do, right? So this is maximum of answer 1 and answer 2, and either this is the answer or this is the answer. Okay, if they are equal, then 1 plus I plus 1 j plus 1. If they are not equal, then maximum of answer 1 and answer 2. Okay, so this will be the case. This is what we have to do in the recursion. This is what we have to call for the recursion. Recursion is actually telling us, recursion is also giving the answer for this part, like I plus the, like common in this part and this part, the recursion is giving us that. Okay, sorry, recursion is giving us that, right? So this is what we have to do, right? So okay, what Now it is okay, guys. Let's continue then, if it is okay, right? So here we have discussed this question, right? We were discussing this question. If you guys have just joined, let me tell you guys about this question again. So we have this longest common subsequence, longest common subsequence, right? Longest common subsequence. Here what we have to do is we have to find the longest common subsequence in both two strings, right? So it is str1 and str2, that we have two strings, and we have to find a longest common subsequence. What does subsequence means? I think you guys know that. What is subsequence? So if a string abc is there, so it will be ab, ac, like ab, like and bc, and you can say a, b, c, but the order should remain same of the alphabets. Otherwise we can delete some characters between them, right? So these are all subsequences. So we have to find a longest common subsequence in two strings, right? So these two strings can be anything, like let's say a, b, c, d, e, and a, x, c, d. Let's say these are the two strings we have. In these two strings, this is the actually question of a lead code that we are doing. Here you can see, not here, here you can see the question as well. Okay, this is the question that we are doing. So here you can see we have two strings given, a, b, c, d, and a, c. You have to find the longest common sequence, length of the longest common subsequence. Okay, so that is what we are doing. Okay, that is what we are going to do. So here, let's say these are the two strings we have. So here, let's say first thing is we cannot find, actually if we try to do it iteratively, we cannot do it because there are a lot of possibilities, right? So this, let's say starting from a, this a and a are equal. So in that case, that is okay. So we will add 1 to our answer, right? Now this b and x are not equal, but this b can be anywhere in this string after it, right? After x, this b we can find anywhere as well. Okay, same way with this c. We don't know where this c is in this whole string. Okay, this will be very, very difficult to find out how many, like the longest common subsequence. It is very difficult to find out, right? It can be one possible, we find all the possible subsequences of this, we find all the possible subsequences of this, we store them in a set, and we then compare. Okay, that will be a very, very big process. That is going to be a very long process, and that is not feasible, right? So what we are going to do actually in this question is we are going to use recursion. Okay, and how we are going to use recursion is because you can see here, this is a very, like, we cannot solve it. It's a very big problem, so we can convert it into a small problem of same type, so that we can solve it efficiently, right? So here we have a, here we have a, right? Both are equal. That means we want to include this a into our substring because we want to find the longest common subsequence. So we want to include it into our answer, right? So that will be, this will actually contribute 1. Like 1 means one alphabet. So this will be +1 into our answer, right? If they are equal. Okay, so this will be, let's say, this also, when we are doing the recursion part, if you guys know that we only work on the first part and rest of the work is done by recursion, right? We'll work only on this alphabet, like the first alphabets of both the strings, and rest of the part will be done by recursion. Recursion will give me the common subsequence of this part and this part. Okay, only we have to see if these both are equal or not. If they are equal, what simply we have to do is, let's say name of the function is LCS. Okay, name of the function is LCS. So in this we have, let's say, I and j. Okay, I and j means this is I and this is j, right? So in this case, what will happen? We will see if I and j, str1.i, like str1.caret I and str2.caret I are equal or not. If they are equal, then what we have to do? In that case, what we have to do is simply we have to return 1 plus whatever is the common in these two. Like in these two, whatever is the common subsequence that we will get by the recursion, that will be our answer. 1 plus, we will call the recursion again, LCS, we will call for I plus 1 and j plus 1. Right? This part of will be done by recursion. We only have to work on the first character. Right? This is the condition when both are equal. Like this is when str1 dot caret I is equal to str2 dot caret j, right? This is there. Okay, now the thing is, if we have this, right, this will be one of the answers. Another answer can be that str1 dot caret I is not equal to str2 dot caret j. That means first characters are not equal. So in that case, what will happen? If they are not equal, like let's say this would have been C. This would have been C. So in this case, what will happen is they are not equal. So either we will find the answer. We will, let's say, ignoring this C. Instead of in these two, what we are doing is, now we are trying to find this whole string. We are comparing it with this whole string. Okay, leaving C beside, we are actually comparing this whole string, first whole string, with the rest of the string of str2. Okay, rest of the str2 we are comparing, only removing C, because they are not equal. So we cannot include it into our answer. Either one of them. Either I don't have to include A, either I don't have to include C. Okay, so what we have to do in this case is, we have to take, like, either we will compare this part, like either we answer 1 can be, we are calling recursion for LCS I and j plus 1. That means I is remaining at the same position. That means this whole string we will compare with this part of the string. Or answer 2. Answer 2 can be, we are doing LCS of, so A and C, one of them we have to take. So in second case, we are taking C. Okay, we are taking this whole string, second string, and we are removing A from the first string. We are not including A into our answer, we are including C into our answer. Okay, so that will be I plus 1 and j. Okay, these are the two answers possible, and what we have to do is, in these two answers we have to take the maximum. So what we have to do is, we have to take the maximum of answer 1 and answer 2. Okay, maximum of answer 1 and answer 2. Either we have to include A, either we have to include C. So one time what we did was, we included A and we removed C from the second string, I and j plus 1. Second case, we decluded, or you can say we removed A. We haven't taken A into our answer. We have taken this part of the string and the whole string second. Okay, that is I plus 1 and j. That means starting from j and here I plus 1. And we have to take maximum of answer 1 and answer 2. Okay, these are the two cases possible. If the I and j, that means first characters are equal or not, then we have to, if they are equal, then we simply have to do 1 plus LCS of I plus 1 j plus 1. Otherwise, if they are not equal, we have to take two cases. Either we include A or either we include C. If we include A, then we have to call recursion for I and j plus 1. That means I remains same, j goes j plus 1, or I plus 1 or j. And we have to take the maximum of answer 1 and answer 2. Right? These are the two things we have to do. Right? So this is the case. And what will be the base case? Base case is simple. If let's say both are empty, okay, str1 and str2, there is nothing there. Let's say either one of them is even empty, so there will not be any common character, right? So in that case, we will return 0. Okay, this is the recursive solution. We are going to convert it into iterative one as well. We are going to convert it into actual iterative DP code as well. So first of all, let's write this code and then we will move forward. So first tell me if you guys have got this part. Whatever we have done till now. I hope you guys have got it right. So let's write the recursive code for it. So we should, okay, so let's write it here. So let's write it LCS. Okay, so public static int LCS. So here we will have two strings, str1 string str1, right, and string str2. Okay, so if str1 dot char at I, okay, and we have to take I and j as well, right? We have to take I and j as well. If str1 dot char at I equal to str2 dot char at I, char at j. Okay, so in this case, what will happen? In this case, what will happen is we have to actually simply give the answer as 1 plus we have to call the recursion for rest of the string, right? So it will be LCS. Sorry. It will be where it is. It will be LCS. Okay, and we have to send the same part str1 str2. Just we have to increase I plus 1 and j plus 1. That means we have included it into our answer. That means 1 has been added, but I plus 1 and j plus 1, this is what we have to do. Okay, else another thing can be, else there are two possibilities now, right? So one is int answer 1, that if we are including I and not j. Okay, so in this case what will happen? We have to call LCS for str1 str2 and I plus 1 and j. Okay, and int answer 2 will be including I and not j. Okay, including I and not j. And LCS, a second answer can be str1 str2 and I plus 1 and j. Okay, and then what we have to do is simply return math.max of answer 1 and answer 2. Okay, this is what we have to do. These are the two answers possible. So let me give you the example as well. So let's say for A, B, C, and let's say A, X, C. Okay, these are the root strings we have. A, X, C, D. Let's say these are the root strings we have. So what we are going to actually do is, we have I here and J here. Okay, so these two are equal. Okay, these two are equal. So what we will do is, we will add 1 plus, so I and J are here, right? So what we actually have to do is, initially I and J will be 0. So let's say this is the box, recursion box of that. So I is 0 and J is 0. Okay, in this case what will happen? We will compare I and J. Whatever is str1, this is str1, this is str2. Okay, so they are equal, right? So what will happen is, we will call recursion for 1 plus LCS of I plus 1 and J plus 1. So we will call recursion for I equal to 1 and J is equal to 1. That means here and here. Okay, here and here. So in this case what will happen? So we have B here and X here. They are not equal, right? They are not equal. So we will go to else part. So there are two things now. Sorry. Answer 1. Okay, first of all, answer 1 will be calculated. So answer 1 will actually go to I or J plus 1. That means I will remain at the same position. That means this part of the string. But J will move forward. Now we will try to find this part of the string in this string. Okay, so this is the case. So now what will happen? We will try to call recursion for I and J plus 1. So I is here and J plus 1 is here. Okay, so J was here, so J plus 1 is here. So we'll call recursion for I is equal to 1 and J equal to 2. I is equal to 1 and J equal to 2. Okay, so let's say this is the only string we have. It will be very big then. Okay, so let's say this is AB and this is AXC, right? So or what we can do is, we can take it B as well, AXB. Okay, so this will be much more. Okay, so we are trying to find this part of the string in this part of the string. Okay, so what is going to happen is, I, here we have I and here we have J. So again this recursion will call. So I and J are equal. Yes, B and B are equal. So what we are going to do is, we are going to call recursion again for this part only. Sorry, 1 plus LCS of I plus 1 and J plus 1. Okay, so we'll call recursion for I equal to 2 and J equal to 3. Okay, we will call recursion for I equal to 2. I will come to 2 and J will come to 3. So they both are empty. So this is the base condition we have, that if any one of them are gone forward, like go to the end of the string. So in that case, what we have to do is, we have to return 0, because now there will not be any common. So from here we will get 0. That means it will be, we have to return 1 plus 0 from here. Sorry. Okay, so here we have 1 plus 0, so we have to return 1 plus 0 from here, so it will actually return 1 here. Answer 1 will be 1 here. Okay, answer when j and I were here and here, x and b, so here we have to return 1. Okay, so let me just remove it. Okay, so, so we are now back to this condition, that where we have x and b. Here we have x and b. I was here and j was here. So here answer 1 was that we are including this b, but we are not including this x. So we are trying to find this b in this part of the string, rest of the string of the second. Okay, now the next thing will be, we are not including this b. We will write the base condition. I haven't written it yet, so let me just write it first. I'll write it. Okay, so that I will write. Okay, so now in x and b, we have included b, now we have to include x as well. Now this is the another thing that we have to think, that first answer 1 we have got, now we want to find answer 2 as well. Okay, now we have to find answer 2 as well. This answer 1, I is equal to 0, j is equal to, this is the main case. Now from here we called for I is equal to 1 and j is equal to 1. From here answer 1 we have calculated, which is 1, but what will be the answer 2? Answer 2 will be actually I plus 1 and j. I plus 1 and j means that I will move forward, I will come at the empty position. Okay, j will be at the same position. Okay, now you can see that if one of the string becomes empty, if even one of the strings become empty, we have to return 0. Okay, so here when it will call for I plus 1 is, let's say here I was 2, I was 1, so 2 and j is 1. So if we are calling for this 2 and 1, in this case it is at 2, that means 2 means the out of the string. So if one of the string becomes empty, there cannot be any common after that. Okay, so here we have to return 0. So answer 1 and answer 2, we have both of the things we have got, so we have to return maximum of them. Maximum of 1 and 0, it will be 1. So from here we will return 1, and here you can say we have to return 1 plus whatever we got the answer for, I is equal to 1 and j is equal to 1. Okay, so from here we will return 2, 1 plus 1 2. So from here we will return 2. So the answer will be 2 for this case. And we can see that here we have AB, here we have AB, so answer should be 2 only. Okay, so this is the case. So this is the case, right? And let me write the base condition as well. So it will be if str1 dot cat at str1 I is equal to str1 dot length. If I equal to str1 dot length, if it reaches end of the string, or j equal to str1, right? str1 dot length, and here j equal to str2 dot length. Okay, in this case what happens, we have to simply return 0. Right? This is what we have to do. Okay, and you can test it as well. Let's test it. So let's call LCS for AB, and here we have to pass 0 0. Okay, and here AB, and let's say ABC and AXB. So this is what we have to do. So let's run it. You can see the answer is 2 because there is only AB and AB here. Okay, but this solution is very, like, its time complexity is very much. Why? Because we are calling recursion again and again for the same part. So worst case scenario will be for let's say I equal to 0 0 I have started, so I have to call for I is equal to 1 and 0 and also 0 1. Okay, this is the case. Or we have to only call for one recursion call. Okay, so worst case scenario, if let's say if we have to call 2 recursion calls every time, so it will be 2 to the power n. Time complexity will be big of 2 to the power n, right? So we have to change it. We cannot actually afford this much time complexity. So what we are going to do is we are going to actually reduce it to the dp. Okay, and why we are going to use dp here is because we have to actually, there are overlapping subproblems. There are a lot of overlapping subproblems. Why there are overlapping subproblems? Let's say we start from 0 0. Okay, then we are going for I plus 1 and j. So I plus 1 and j will be let's say 1 0, right? And here 0 1. Okay, now again let's say it calls for 1 1. Okay, it can call for 1 1, or it calls for 2 0, right? and this actually can reach to 20 as well. At some point it can also reach to 20. How? So let's say it is 1 1 first of all, then it reaches to 2 1. Okay, 2 1 it can reach to, and this can also reach to 2 1, right? So these are the conditions. We will actually get some of the common subsequences. This 2 1 2 0, these are actually I and J I am talking about. So they can actually repeat themselves. So we can actually use DP in this case because there are overlapping subproblems. Okay, so this can be possible. So in this case we can actually use DP, and how we are going to use it, you can see here two things are changing, I and J. Okay, that means if we take a DP array, 2D DP array, okay, 2D DP array if we take, okay, in that case what will happen, we have to actually sorry sorry guys. Okay, so if we take 2D DP array, so we can take I and J and we can change the things, right? So let's say how we can do that. So let's take example of a string, and then we will see how we can do that. So let's say let me go to an empty page. Here we have, let's say, str1 and str2, right? Here if we have ABC, right, and here we have, let's say, AXB. These are the two strings we have. Okay, now if I take a 2D array, here we have I, we start I from here and J from here. We know by recursion these things, right? How it can be m into n? It can, sorry, my voice. Okay, so let's start. So here we have I and here we have J. Okay, so what we are going to do is we are going to take a 2D array of what length? Like this length and this length. Okay, let's say this is 3 and this is 3 as well. So it will be 4 into 4 actually. We always take one length more. Okay, so it will be 4 into 4 DP array. Okay, so it will be 4 into 4 DP array. Okay, here we have, let's say, 0 1 2. Here we have 0 1 2. This 0 1 2 represents, this is actually A. This is the first string. This is str1 A B C. Okay, these are the indexes. This is 0 index, this is 1 index, this is 2 index. This 0 represents A, this 1 represents B, this 2 represents C. Here at the column part, this is the second string, AXB. Okay, so this 0 represents A. So this 0 represents A, this 1 represents X, and this 2 represents B. Okay, so what we are going to do is, actually in this part, first of all, as we always do, we start from a very small problem. In DP, what we do is we start from a very, very small problem, right? So here the very small problem that we have is we have to see actually the number of, like, if there are overlapping subproblems, we have to see that. If there are overlapping subproblems, then only we can use DP. That is the main thing. Okay, so here there were overlapping subproblems that when we tried to do it with the help of recursion, we found that there were overlapping subproblems. The cases were repeating. So we are just storing them in a DP array so that next time when we have to use it, we will directly use it. Okay, so here you can see that we have to start from a very small case. So here you guys know that if the string is empty, let's say if the string is empty, so that means if we reach the end. So if we have seen the base case, what was the base case? Base case was that if we reach the end of the string, if we reach the end of any string, so this represents string 2, right? 0 1 2, this represents A, this represents X, this represents B. So now when we reach the third index of this string, or we reach the third index of this string, that is empty. Okay, that is empty. That means if we have an empty string, even one of the string is empty, so then the answer will be 0. So these all will be 0, right? We know that this is the extra row and column that we have taken. So if any one of them is empty, so let's say this is empty, and we try to find the empty string and common with this string AXB. So this will be 0 only. The answer will be 0. That we want to find the longest common subsequence. So longest common subsequence will not be there. If one of the string is empty, there will not be anything common. So the answer will be 0. So this is the 0 case. Now what we actually want is, if let's say C and B are equal, we are going to start from the end. Okay, so there are two cases, right? So if they are equal or if they are not equal. Why we are starting from the end is because we know the answer for these. Okay, we know the answer for these. Okay, so as we have seen in the recursion as well, we were either calling for I j plus 1 I plus 1 j or I plus 1 j plus 1. These are the three things we would need. Okay, here you can see that we have all the three things. If I start from this column, I have this one as well, I plus I j plus 1, I have I plus 1 j as well, I have I plus 1 j plus 1 as well. I have all the three columns. So I can actually start from here. Okay, and this actually represents second index of second string and second index of the first string. Okay, so you can see here C and B both are not equal. They are not equal. So we know the case. If they are not equal, what we have to do? We have to actually see the maximum of I and j plus 1 and I plus 1 and j. Okay, we have to see the maximum of this part. Like we go forward for this part and include this, or we include C and we forward with this part. Like we don't include B or we don't include C. These are the two cases. That means I plus 1 and j. Okay, and j and I plus 1. Okay, we have to take the maximum of them. So here you can see both are 0. So the maximum of them, I plus 1 and j and I plus 1 both are 0. So maximum will be 0 as well. So the answer will be 0. Okay, so the answer will be 0. Right? This is the case. This is the first case that we have to see. Just try to understand it. What I am doing is, let's go back to recursion code as well. So let me go back to recursion code as well. First of all, here you can see DPP somewhere. Yes. Here you can see that if they are equal, we have to actually go I plus 1 j plus 1. Right? If they are not equal, then we have to actually take maximum of I j plus 1 and I plus 1 j. That's why I actually write recursive code first, so that you guys know. Okay, what we actually have to do. We already know the concept in recursion part. Then actually we can convert it into DP very easily. That is the main thing. Okay, so here you can see we can directly use I plus 1 j plus 1 if they are equal. If they are not, we have to take the maximum of I j plus 1 and I plus 1 j, right? And we have to put that in our DP array. Okay, so let me just go back. Here you can see that. So here we sorry, where it was, I was at this, right? And let's go back. Okay, so here now we have, let me just make it a little less clumsy so that you guys know how it is working. Okay, so let me write strings here, str1 and str2. Okay, here we have ABC and here we have AXC, right? And here you can see that, this represents A, this represents X, this represents C, and this is empty and this is empty. Okay, just a second guys, my battery is running low. Give me a minute, let me just join. Okay, so let's start again. Sorry. Okay, so now you can see that we have 0 here, because here this represents 2 and 2, right? 2 and 2 index, that means this index and this index, right? This is I right now and this is j. Okay, this represents I and this represents j. So I and j right now is at 2 2. Okay, I equal to 2 and j equal to 2. That means dp of 2 2. We are actually filling dp of 2 and 2, right? dp of 2 and 2 will be, so this is actually I. Like we know that I is columns, like rows, and j is columns, right? So here this row is actually represented by I and this row is actually represented by j. Okay, so these columns, these are I and j. Okay, these are I and j. You know as well here from here as well that str1 is this, so this is I and this is j. Okay, so dp and 2 and 2 will be maximum of d, because they are not equal. Sorry, they are equal. Before they were not, right? So AXC and ABC, they are equal. I thought they are not. So okay, before this I was taking the different string, I think. Okay, that is also okay if they are equal. So if they are equal, what we have to do is simple thing we have to do is we have to actually take 1 plus I plus 1 j plus 1, right? 1 plus dp of I plus 1, that is 3 and 3. Okay, if they are equal, C and C are equal. So here C and C both are equal. So if we take that 1 plus dp of 3 and 3, so dp and 3 and 3 is 0. So 1 plus dp of 3 and 3 will be 1. Okay, so here I will fill 1. In this case, if we have ABC and AXC, they both are equal. So we have to include it into our answer. Okay, so in that case, what we will do is, now what we have to actually do is, we will get the answer as 1 and 0. Okay, 1, because 1 plus dp of 3 and 3, dp of 3 and 3, diagonal one. That means we have to actually move forward, and both are there is nothing, both are empty, so the answer will be 0 only. So 1 plus 0 will be 1. So here I will fill 1 as the answer. Okay, this actually represents that if we had only C and C in both the strings, if we had only C and C in both the strings, the answer would have been, longest common subsequence would have been only have one length. Okay, because both are C, so the answer will be 1. Okay, now let's move forward. Now let's go back a little bit here. Okay, let's come to this part. Here also we know the answer of all three columns, right? So we can go to this part. So here it represents 2, C is at the same position, C is at the same position for I, but it is 2, it is 1. Okay, so we have to take this part. Okay, we have to take this part, I and J. Okay, these are I and J, right? So in this case what will happen? They are not equal, right? They are not equal. So in this case what we will do is, we will take the maximum of, we will, C and X are not equal, right? So we are actually trying to find out the common between this and this. Okay, what is the common subsequence if we had only C here and here we have XC? So in this case what will happen is, we have to take, if they are not equal, so we have to take the maximum of I plus 1 and J, dp of I will be there, I and J plus 1. Okay, or dp of I plus 1 and J, I plus 1 and J. Okay, this is what we have to do. So here at this position we want to find out dp of 2 and 1. We want to find out dp of 2 and 1. So this I is 2, right, and J is 2 as well. So dp of 2, and here we will have dp of 2, 1, right, dp of 3, 1, 3 and 1. We have to find the maximum of that. So yes, see, there are two types of approaches. Right now what approach we are following is top-down approach. Sorry, bottom-up approach. Bottom-up. This is bottom approach. We start from bottom and we find the answer at the top. There is another approach as well that you are saying, we can start from here. Okay, we can take extra columns here as well, and we can start from here. That is top-down approach. Whatever you want to do, you can follow, but I follow this approach because I find it easy. Okay, starting from the last part, that is a little more easier, right? So now what we have to do, dp of 2, 2 and dp of 3, 1. So the dp of 2, 2 is no, dp of 2, 2 cannot be possible. 2, 1. Yeah, dp of 2, 2 is this one, right? dp of 2, 2 is 1. That means 1, and dp of 3, 1 is 3, 1 is 0. So maximum of 1 and 0 is 1, right? So that means the answer for this will be 1. That means the common subsequence between C and XC is 1. Longest common subsequence is 1, and that is true. There is only one. CC is possible, right? Now what we are going to do? Now we have to move here. Here for this column as well, we know all the three things, right? So what does that mean? That 0 represents A and 2 represents C. So this represents that we have to find now the common subsequence between this whole string and this C. Okay, this whole string and this C. So we already know when A, right now J is at A. Okay, J is at A. Okay, this represents J and this represents I. So J is at A. Okay, A and C are not equal. Okay, when they are not equal, what we have to do? We have to do the same thing. We have to take the maximum of these two. So that will be 1. Okay, this is what we have to do. And what does that mean? That means that AXC and C, what is the common subsequence between them? So what we are actually doing is, we are fixing this C and we are finding the common subsequence with all the strings, right? And we are storing that. Same way, then we will find BC. We will take BC and we will find one by one same thing for this BC as well. That what is the common subsequence of BC with C, then BC with XC and BC with AXC. But is actually helping us is that we already know some answers. Of the previously that we have calculated. Okay, so let me tell you that now let's come here. Okay, here it is C. Okay, it is C only, and here we have B. That means BC and C. We want to find the common subsequence, right? So we already know the answer. So if we want to find the common subsequence, we will see that if C and B are equal or not. Okay, they are not. Okay, if they are not equal, then we have to take the maximum of what? This and this. Okay, and this we have already calculated and stored. If we didn't know these two things, then we have to go forward and calculate them as well. Okay, this means that we know the common subsequence of C and C, right? We know the common subsequence of this part and this part. Okay, so that is easy. So we already know that, so we will directly use it for the maximum. Okay, so we will take maximum of 1 and 0, so that will be 1, right? Because C and B are not equal. If they would have been equal, that would have been changed the whole scenario. Okay, so now they are not equal. Now they are not equal. So what we will do is, again, when we come here, now XC and BC, we have to find the common subsequence between them. Okay, we are at X and B. So they are not equal. Again, same thing, that we have to first of all take the maximum of this and this and maximum of this and this. Okay, and we already know the maximum of this and this that we have just calculated, right? This was the one, right? So this part and this part, like I and j plus 1, this part we already know. Okay, so this is what is helping us. We don't have to actually calculate this again and again. We have actually stored them. Okay, so being less confusing here, so what we actually have to do is, simply we have to see X and B. Okay, here we have X and B. Okay, they are not equal, so we have to simply do the maximum of this and this. That means I plus 1 j and j I plus 1. Okay, sorry, I j plus 1 I. So in this case, the maximum will be 1. So that will be the answer. Now we are at B and A, right? So we are at B and A. That means this part and this part. So in this case as well, they are not equal. So we have to again do the same thing, maximum of this and this. That will be 1. Okay. Now coming to the last part, that will be we are at C, and here we are at B. That means we have to take this whole string and we have to start from C, comparing them. So ABC with C, what will be the answer? Max, like common between them. A and C are not equal, right? So we have to again take the maximum of these two, that will be 1. Then we have XC and ABC. So X and A, right? X and A, we have to take X and A. This column represents X and A, X from this and A from this. So they are not equal again. So we have to take the maximum of these two, that will be 1. Now when we are here, they both are equal. A and A both are equal, right? So what we have to do, we have to take 1 plus dp of I plus 1 j plus 1. That means 1 plus dp of I plus 1 j plus 1 is 1. So that will be the answer will be 2. Okay, here the answer will be 2, and we know that for this string the answer will be 2 because AC and AC. This will be our answer. Okay, so the answer will be 2. This is what we have to do. Okay, only thing you have to focus on, if you don't want to go into more detail, like you find it very difficult to understand it, you should. But the main thing what you can do is simply write a recurrence relation with the help of recursion. Okay, we already know for any strings. Let's say two strings are given to you, ABC and AXC. So first write the recurrence relation. Recurrence relation will be, if they are equal, what we will do is we will take 1 plus LCS of I plus 1 j plus 1. Okay, if they are equal, we know that we have to include this one into our answer. Otherwise, what we have to do, if they are not included into our answer, so we will take I. Simply we have to take this part and this part. Okay, or this part or this part. If they are not equal, let's say this would have been C. So if they are not equal, we have to take this part and this part, or this part or this part. Maximum of these two. Okay, either we can include A or either we can include C in our answer. Okay, so that will be maximum of LCS of I j plus 1 and LCS of j plus 1 I. Sorry, I plus 1 j. So why I am writing this recurrence relation is because this recurrence relation can directly be converted into DP code. Okay, because we just need the recurrence relation and we have to think that, okay, we have to make a 2D array. Okay, base condition was that if they go out of the string, so we have to return 0. So we'll take a extra column and row and we will add 0 there, and we have to just use this recurrence relation. So let me just directly write the code now. Okay, so let me just tell you guys that with the help of this recursion, you can see here the recursive code, how we can actually write the DP code. Okay, how we can directly write the DP code. So public static int, and what is this? This is LCS, right? LCS DP. So in this case, what we have to do is we will get string str1 string str2, right? So these are the two strings we will get, and we have to take a DP array. Int DP is equal to new int str1 dot length str2 dot length. This is the thing that we have to do. Okay, now we have and it will be +1 +1 as we have already discussed. We have to take a +1 +1, and here we have to take +1 as well, +1. Right, now what we have to do? Simply we have to actually we don't have to fill this 0, right? You can see here we don't have to fill the 0 because initially when we actually make an array in Java, all the things are 0. Okay, so we don't have to go there and fill 0 because they are already 0. We have to change the value. Right, now what we are going to do is we are going to start from int I equal to str1.length. We have to start from the last str1.length -1, and we will go till I should be greater than or equal to 0, I minus minus, right? And for int j equal to str2.length -1, j should be greater than or equal to 0 and j minus minus. Okay, so this is the case. Now what we have to actually do? We have to take the same. See, now nothing much has to be done. This is the only thing that we have already done, this reconciliation. We have to actually paste it here, Control V. Okay, we have to directly paste it here. Only thing that we will change is that instead of this calling the recursion, what we are actually going to do is we are going to take a DP array and we will use it there. Okay, this is the only thing that we have to change. Right, here as well, same thing. We have to take a DP array. Okay, here as well, same thing. Instead of this calling for recursion, we have to use the DP array. Okay, so this is what we have to actually do. Okay, and it is done, and the answer will be at dp of 0 0. You just have to return dp of 0 and 0. Okay, dp of 0 and 0. This is what we don't have to return, actually we have to store this thing. dp of ij will be this, and dp of ij will be this. Okay, so this is the case, because this is the case, and if we find out LCS DP, and we try to find out the answer here, you can see the answer is 2 that we have already calculated, right? We have already calculated this answer. How to do that? So we have written this. Okay, so anybody has any doubt in this, like how I have written this? We just have to think, first of all write the reconciliation, whatever the reconciliation we need, that will be helpful in DP code as well. We just have to think okay, we have to take a 2D DP array, okay, 2D DP array, and from where we want to start. If we are starting from here, then we have to these are just space conditions that we have to write here. Okay, when we reach the end of any string, what we need, we have to fill it here, and then we have to start from here and keep going forward and use the same reconciliation that we have actually found out in the recursive code. Okay, that is what we have to do. Initially, if you are doing coding for the first time, like DP for the first time, you can use this approach, but as we move forward, we have to think the logic as well, like how actually what we are doing. Okay, how actually what we are doing. So every column here represents something. Every column here represents something. That is what it represents, is the what is the maximum answer, like it is actually showing the answer. What is the maximum longest common subsequence starting from this position of this string to this position of this string? Okay, this part, what is the longest common subsequence for this part of the string? This part means, let's say this would have been ABC, this would have been AXC. So what is the common subsequence between this and this? Any column will represent that. If we are at here, it will give the common subsequence for this. So every time so what is DP and what is recursion? We start from a very small problem and we keep going forward. And actually find the answer. Okay, starting from small problem and we keep increasing it so that we reach the end. Okay, that is recursion or any DP problem, which is actually the same thing, which is actually based on that concept only. that solve the small problems and then move to the bigger problem. And we are doing the exactly same thing. We start from a small problem and move to the biggest problem with the help of that. Okay, that's why we say that DP is used in optimal substructure problem as well as we need a overlapping subproblems. These are the two things we need for DP problem. Okay, I hope this is clear. So okay, this would have been same as well. We can submit it as well or not. We can try this. Okay, so let's try to submit this part. If we use recursion will DP, that is called memoization. DP is actually used in like memoization is mixture of DP and that. We are storing the values while returning it and then we are actually using it. Okay, so that is actually called memoization. Here I'll change it to str1. This text one I can change it to str1 here as well. Text 2. Change it to str2. Okay, so let's try it now. Yeah, it is working fine, so let's submit it as well. Yeah, you can see here the answer is exactly correct. Okay, it is faster than 96% and all the solution, and this is good, right? It's a good solution. Submit it for the first time. Yes. Okay, so I hope this is clear. Anybody has any doubt can ask. Simple code it is, right? It was also a medium level question, right? Yeah, so you guys have reached the medium level questions as well of lead code of DP as well. Okay, so I hope this is clear, guys. Any doubt in this? So that we can move to the next question. So next question that we are going to do is edit distance. Okay, edit distance. So today I have taken both the string type of questions. So this is also based on strings only. So let's find out edit distance lead code. Okay, so let's open it. Edit distance. This is a hard level question. Okay, this is a hard level question. Let's see it. But the question is, and this is actually easy. Okay, it is actually easy. It is based on the same concept that we have done till now. Okay, same concept but a hard question because something you have to think in this as well. Okay, so here given two strings word1 and word2, return the minimum number of operations required to convert word1 into word2. Okay, there are two words given to you, word1 and word2. You have to convert one word into another. Okay, you don't have to actually convert it. You have to find the minimum number of operations. You can convert one string into another. How many minimum number of operations can be there? This is called edit distance. Okay, and you have the following three, only these three operations you can do. Either you can insert a character, delete a character, or replace a character from any string. Okay, here you can see we have horse, and here we have Ross. These are the two strings we have, right? So here we have H and here we have R. They are not equal, right? So there are three possibilities that we can do. Either we insert one, either we delete one, or either we replace a character. Okay, so let's see what we can do. So let me just try to do it here only. Three operations. What are these three operations? Horse and Ross. These are the two strings we have, str1, str2, right? So here you can see we have H and R. First of all, we'll try to compare them. Okay, we want to find out that we have to make one string equal to another. Okay, that is the main purpose, and these are the three operations that we have. Either, let's say we are working on this string, so R and H. So either I insert H here. Okay, either I can insert H here. This is the first thing I can do. Okay, if I insert H here, so what will happen is like work of this and this is done. We have made them equal. So we will actually, so let's say this is I. We start here from I and here we start from J. Okay, this H was not there. This was only Ross, and this was only horse. So this, let's say I am inserting h. So what will happen? So they will become equal, h and h will become equal. So I will move forward, I will become I plus 1 and j will remain at the same position. Okay, because we have inserted the character. So first answer one will be we have to take I plus 1 and j. Okay, I plus 1th part of the first string and this whole part of the second string to make them equal. Okay, if we are inserting a character, this is the first operation. If we are inserting, here we have h and we have added h here as well. So when we have added h here, so j will remain at its own position because h has been added before it. Okay, and this h, as they have become equal, so we have to move forward. Okay, so the first answer that can be a common string from I plus 1 to and j, like this part and this part. Okay, this is the first answer that we can get. Second is delete a character. Second thing is we can delete a character. So in that case, what will happen? Let's say it was Ross only and it would have been horse only. Okay, so in that case, what we can do is we can actually compare these two. Okay, they are not equal, so we have to delete a character. So either we delete a character from here or here. So it will be more functional that we delete a character from here. Okay, so we have deleted the character from here. Let's say h has been deleted. So I was actually at h, right? I was actually at h. So what will happen? In that case? So we have to work on only one string. Okay, we cannot work on both the strings simultaneously. We have to try to make one string equal to another. Okay, so if we are inserting in this string only, so we will delete from this string also. Okay, this is what we are doing. So let's say I remove r. We are removing r from here. Okay, let's say I remove r. So I was there only. Okay, so but j will move forward. J will become j plus 1. Right. So that means answer 2 can be common between I and j plus 1. I'll explain what I am writing here. So I am just writing the cases. Okay. Now third thing will be that here we have horse and here we have Ross. We replace a character. So we can make this r equal to h. So I can make this r equal to h. Okay, they can be equal. So in that case, we have to, if they both are equal, so we have to move both of them, I plus 1 and j plus 1. J will also move, I will also move. So third answer can be I plus 1 and j plus 1. Like common between I plus 1th string and I plus jth string, because this answer has been actually, we have changed it. They both have become h. Okay, so that will be this. Okay, so this actually, whatever will be the maximum. Whatever is the maximum of answer 1, answer 2 and answer 3. Okay, whatever will be the minimum, we have to find the minimum steps. Minimum of this plus 1, that will be our answer. 1, why? Because this operation that we are making them equal. Okay, that will be the operation. Okay, we are either deleting, inserting or replacing. So that is the one operation, right? We are doing one operation. So that's why I am adding 1 to it. But this 3 things, that finding the minimum of all these 3 cases, that is the main thing that we have to do. Okay, that is the main thing that we have to do. 1 plus minimum of answer 1, answer 2 and answer 3. Right? What are these 3 operations? That we are inserting a character, then what will happen? That this is that work done by recursion. Okay, this is the work done by recursion, that we are actually calling the recursion for I plus 1th string and j. We are only working, see, in recursion, we only work on one character of both the strings, right? Let's say we are working on the first character, then these are the 3 cases we got, that either we are deleting, inserting or replacing a character. Okay, so this is what we have to do. I hope the question is clear. First thing, that if we have 2 things, horse first string and Ross second string, then what we have to do is we have to make them equal. We are trying to make them equal. So we have h here, we are r here, we are working on only one string, because we have to when working on recursion, we have to work on a small problem and rest of the work is done by recursion. So this is the small problem. Let's say we have only h here and we have r here. Okay, we have to see if they are equal or not. We want to make the whole string equal, both of the strings equal. So let's say I am trying to make this string equal to this string. Okay, so in that case, what will happen? If they are not equal, if both the characters are not equal, we have 3 operations with us, that we can do either of the 3 operations. Okay, the first operation that we want to do is insert. Okay, so whatever operation will give me the minimum answer, that I will take. Okay, either I insert it, either I delete it, or either I replace it. Okay, so here we have h, here we have r. If they are not equal, what we have to do? We have to insert a character. First thing is insert a character. We are inserting h into the second string. So this is str1 and this is str2. Okay, if we are inserting them, so let's say this was I and this was j. This was I, this sorry, not this was j, this was j. Okay, this was I and this was j. So in that case, if they are not equal, we have three operations to do. So let's say first operation is inserting. So in that case, if we have inserted it, so h and h are now equal. So what we have to simply do is we have to move forward with I, but j will remain at r only. Okay, so let's say the name of the function is min distance. So I will call min distance for now. We have already found the min distance for h and h. Okay, now we have to find the min distance for I plus 1 and j. Okay, I plus 1, that means this part and this part. This was for insertion. Okay, now let's come for, after that what we have to do is we have to do it for delete. Sorry, second operation is if we have to delete a character. So if we want to delete r, okay, so what will happen is I will remain at the same position but j will move forward. So we have to find the minimum distance for now rest of the string, that will be I and j plus 1. Okay, j plus 1 means r is removed, so this is the string left from j plus 1 to end, and here I will remain at the same position. Okay, now the third thing we can do is we can replace a character. So replace means we can replace this r with h. Okay, we can replace this r with h. So if we make it h, okay, they are equal now. So I was here, j was here. So now when they are equal, we just have to move forward. This will become I plus 1 and j plus 1. So we have to call the minimum distance for I plus 1, j plus 1. I plus 1, j plus 1. Okay, and we have to take now the minimum of all three of operations, and we have to add 1 to it because we have done one operation at least. Okay, either this or this. And this was the case when they are not equal. This is the only case when they are not equal. If they are equal, so let's say this would have been HOS and this would have been HORSC. So H and H are equal, I and J, I and J. Both the characters are equal. So we just have to move forward. In that case, we will just have to move forward. Like recursion will tell me, okay, this part and this part. What is the common between this part? Like what are the minimum operations we have to make them equal? So that will be done by recursion. If they are equal, then we just have to call one recursion call. That will be min distance, I plus 1 and j plus 1. I plus 1, j plus 1. This is the only operation that we have to do if they are equal. Okay, that will be 1. Sorry, it would be 1 as well. 1 we don't have to add in that case. Why? Because we are not doing any operation. They are already equal. Okay, so this case is when they are equal, and this case is when they are not equal. The first character that we are working on, if they are not equal. So this is the case. Now we got the reconciliation. We can directly convert it into DP as well. Okay, so before going into DP, what we can actually do is we can actually write the recursive code, see if it is working correct, then we will move to the DP code. Okay, just let me know if you guys have got it. Whatever the approach I have told you, just let me know if you have got it. I hope this is clear. So let me write the recursive code first, right, and then we will go to the iterative code, right. So let's write the recursive code here only, or let's write it here first. Okay, so min distance we have both the strings, right, and we have int I and j, int j, right. And the base condition, let me tell you about the base condition as well. What will be the base condition? So let's say this is ABC and this is A only. Okay, so we will find out they are equal, right? But now the rest of the string which is left, okay, so this has to be inserted in this string. Okay, we have to insert it into this string. So these operations, like how the string that is left, that is actually will be our base case as well, that if BC, like whatever the string is left in one of the strings, that we have to return that length. So what I'm trying to say here is, so let's say the two strings are ABC and A. Okay, so now if we can only find A are equal, so it will call for recursion for not 1, so it will call for recursion for this part only and the empty part. Okay, so now if this is empty, we have to make them equal. The question is we have to make both the strings equal. So these characters has to be inserted in this. That will only be the one operation, right? Only one operation is possible in that case. So we have to, whenever we reach that one of the string is empty, so we have to actually give the remaining length of the, return the remaining length of the next string, another string. Okay, let's say if this string becomes empty, so we have to return the remaining part of the string 2, remaining part of string 2, that is what we have to return. Okay, that means we have, if this is I, we have to return I, here we have to return J. Okay, if this becomes empty, we have to return J, if this becomes empty, we have to return I. Okay, this is the case. So what we are going to do is, if str1 dot length, if str1 dot length, sorry, not str1 dot length, we are not, so if I equal to str1 dot length, str1 dot length, in that case what we have to do, we have to return first string is J. Okay, wherever the J is, sorry, not J, we will actually return str2 dot length minus J. Right? Why? Because let's say this is the string A, B, C and A. Okay, so if we want to make them equal, so A and A are equal, so now we have to insert this BC, exactly BC into this string. So if if let's say this is str1, this is str2. So if str1 becomes equal to length, so I comes here, that means it is equal to str1 dot length. Okay, so if it is equal to this, so what we have to do is we have to return wherever the J is. J would have been here, J would have been 0, 1, it would have been 1. So we have to return, what is the length of this string? We have to 3 minus 1, that will 2. Okay, we have to return BC, that means the length of BC, whatever is left. So let me tell you again, it is a little okay. So str1 is A, str2 is B, ABC. Okay, what will happen? What will happen is we will start I from here and J from here. Okay, so if they are equal, we want to make both the strings equal. So A and A are equal, we don't have to do anything, we will just move forward. So this is 0 index, now I will come to first index and J will also come to first index. Okay, so now when I and J both are at first index, we can see that first string has become empty. That means I equal to str1 dot length. str1 dot length is 1, so I is now at the first position, which is equal to str1 dot length. That means this has become empty, str1 is empty. So only one case is left, is that whatever is the number of elements left in the second string, that length we have to return. Okay, because this 2 has to be added into our answer, because we have to insert it into the first string to make them equal. So J is at 1 right now, so how we will get the length of this remaining string? That will be str2 dot length, whatever is the str2 dot length, which is 3, minus wherever the J at right now, right? J is at 1, so 3 minus 2, 1 will be 2, so BC, the length of BC is 2, so that is what I am returning here. Okay, this is the case when one of them becomes empty, and same for the second one. If second one becomes empty, what we have to do? If J equal to str2 dot length, in that case what we have to do is str1 dot length minus I. Okay, str2 dot length minus I. This is what these are the base cases, right? Now what we have to do is simple cases. Now let's come to the simple cases. If they are equal, str1 dot char at I equal to str2 dot char at J. Okay, if they are equal, what we have to simply return is we have to just move forward. We don't have to do anything, right? If they are equal, then there is no operation we need. Okay, if they are equal, there is no operation that we need to do to make them equal if they are already equal. So str2, and we have to move to I plus 1 and J plus 1. Okay, else what we have to do, now the condition is they are not equal. So there are 3 cases as we have discussed. So answer 1 will be if we are inserting into the, let's say, second string, if we are inserting. So what will happen in that case? Answer 1 will be min distance. We have to find the answer for min distance. Okay, that will be str1, str2 and I, J plus 1. Okay, int answer 2 will be equal to min distance, right? str1, str2, I plus 1 and j, right? This was the other case, and third case was both of them if we are replacing them. Okay, so answer 3 will be min distance, str1, str2, I and j plus 1. Sorry, I plus 1, j plus 1. These are the three cases possible. One is for inserting. This case was for inserting. This was for like deleting the character, and this one was for replacing the character. I have already explained this, right? Now what we have to do is we just have to take the minimum of all three and add 1. So we have to return 1 plus math dot min of answer 2, answer 3, and also math dot min math dot min of answer 1, answer 3. Okay, all the three, minimum of all three, right? This is what we have to do. This is the only thing we have to do, and the question is that, right, we will find the minimum distance with the help of this. Okay, so minimum distance, let me call that min distance, right? And we have to give two strings, and here we have to give 0 0. We have to start from 0 0. And if I run it, answer should be 1. Answer is 2. ABC, yeah, answer will be 2. Okay, why? Because if we have ABC and AXB, so in this case what will happen, A and A are equal, so we have to only replace these two, like we have to change these two. So here we have B, okay, and X. So three things are possible, either we insert it, delete it, or we will try all the three operations. So what we can simply do is we can make B here, right, and here we can make C. So these two operations, actually we have to do these two operations, right? These are the two operations possible, right? Other operation can be, we can replace them with B, or we can delete will not work because we have both are of the same size, and inserting will also not work because they are also of the same size, so that will be more operations. So it has all found us the minimum one. It has found us the minimum answer. Okay, so that is this way. Okay, this is the way that we find a minimum answer. If anyone has any doubt, guys, just let me know, because a little bit tricky this question is, and this time we are directly going to convert it into DP without going into the actual logic. Okay, then we will go into the logic, that is okay, but we are going to convert it into DP like very easily. Okay, just like so you know, if you are able to write the recurrence relation, it will become very easy for you guys. Just let me know if this is clear, like how we are finding this. Just let me know, guys, if this is clear. Okay, so let's move forward and write the DP code for it. Okay, same way. See, whatever we have done in the previous question to find the subsequence part, okay, longest common subsequence, we have to do the same thing. See, base cases, we will take a DP array. Simple thing, let me just tell you. We will take a DP array. We know that I and J are changing. Two things are changing, I and J. So we'll take a 2D array where I will represent one string and J will represent one string. Okay, we'll start from the end. Okay, because we are working on I plus 1, J plus 1, these things. So these three things we already know for the end one only. Okay, we'll start from here. We'll keep going up and use these recurrence relations. Okay, and we'll find the answer here. The only thing is this thing. This thing is that when I will become str1.length, that means the extra columns and rows that we are taking. So the extra columns and rows, this one extra row and one extra column we take, right? This actually represents the base cases, right? That I will, this is str1.length and this is str2.length, right? str1.length, str2.length. In this case, we have to actually put this part here. We have to actually put this part here. What does that mean? That let's say this is ABC and this is AXC. Okay, now we are here. Let's say we are here. So what we are actually have to do is, if let's say this would have been A only, and this is ABC, right? This is ABC, and we are at the empty string now. We are at the last string now for this string. Now this is only A. Okay, so what we have to do, what we have to actually do is the base case will be str2.length minus 1. Okay, str2.length minus j. Okay, that will be if let's say abc is there, okay, and an empty string is there, the answer will be 3 because we have to insert all these 3. Okay, now let's say there would have been abc and let's say only a there, so the answer at least would have been 2, right? So this is what we have to fill here. If we are at the empty string, let's say second string has become empty and there is only one a only, so we have to insert it. So here it will be 1. So here we have ax and the string is empty, so the answer will be 2. Here we have axc and the answer second string is empty, so the at 3 characters we have to insert. This is the base case, right? Same here as well. If first string is axc and the other string is this, like empty, okay, axc and this is empty, so in that case what we have to do is again 4 or again 3, I think. Okay, again 3. So this would have been 0 1 2 3 actually. So 0 0 0 index, so here would have been 0, so the answer would have been 1 2 3, right? And here also the answer would have been if this string has become empty and here we have 1, so answer will be 1, answer will be 2, and answer will be 3, right? And in this case if both are empty, so the answer should be both are empty means both are actually abc and abc, right? Both the strings have this much, so in that case we have reached the end, right? We have reached the end, so the answer should be 3, right? Yes, I think the answer should be 3. Here the answer will be 1 2 3, and here as well abc and empty, so the answer will be like this only, right? Okay, just a second, let me just think about it. It would have been this or this. So these are the actually base case only we have to think about. Other than that, this question is simple. So let me just first of all write the simple code, then we will come to the base case, right? Then we will come to the base case, right? So let me just write the simple code first of all, converting this part into the DP code, and then we will see where we are actually getting stuck. Okay, so here we have public static int public static int and min distance. Okay, min distance dp, right? And what we are actually going to do is simply convert this code into ours. Okay, so same thing, we are going to start from the end. Int I equal to str, so 2 strings we have to take here, string str1, right, and string str2. Okay, now we have I is equal to str1 dot length right, and I should be, we have to start from the end, str1 dot length minus 1, I should be greater than equal to 0, I minus minus, same code that we have seen before as well, right? For subsequence part we have to start from the last column, and int j equal to str2 dot length minus 1, right? J should be greater than equal to 0, and j minus minus. What we simply have to do is we have to just copy this code again, right? We have to copy this code again. Okay, if they are equal, then we have to simply go for the DP code. DP okay, second thing is okay, so DP I haven't taken till here, so let's take a DP array as well. Int is equal to new int str1 dot length, right, and str2 dot length. Plus 1 right? So this is the simple DP array. Here as well we are going to do the same thing, we are going to convert it into DP, same reconciliation, just use it with DP. Okay, maximum questions, if you have any doubt in logic or anything, so that will be actually be done by this only. Okay, just think about the reconciliation. Just take a TP array, take a bottom approach, and you will be able to solve the TP question. This is a sort of a trick. Okay, but you always have to know like what is actually happening. Okay, so same thing as I have told you before as well in the previous question as well. Each column represents something. Okay, so this column represents the actual answer. If there would have been ABC here, C here, and also ABC here, AXC here. Okay, so in that case, if we want to make them equal, if they are equal, then this column will represent actually this and this. Okay, this part of the string and this part of the string. This will actually represent that. Okay, then we will move forward. It will represent this and this part, and this part as we keep moving forward. So we keep showing the answers, and at last we get the answer at the top. Okay, this is what we are doing. Okay, so here sometimes what will happen is we cannot start from here as well. We have to start from here. We will do that question tomorrow, knapsack 1, where we will be starting from here instead of here. Okay, so we have to think where we can start from and why we are doing from that. Okay, here I know all the 3 answers, that's why I can start from here. Okay, here we have C, here we have C, here it is empty, here it is empty. So the answer will be, if both are empty, answer will be 0. So this will be 0. Okay, if there is C and C, 1 and 1 only. So in that case, what we have to do is, here the answer will be, here it is C. Okay, here it is C only. So answer will, sorry, okay. So the base case will be 0, 1, 2, 3. Okay, here also it will be 1, 2, 3. So let me just explain it, what base case I am talking about. So what see, this is this is I think clear. Like this is sorry, this is a simple case, right? This is actually clear. I hope this is clear that how to convert the simple code, like simple recursion code, into DP code. Okay, like we can do it like this. We already have this. We have to just start from the last column, in the bottom approach. How we have to think it is that if we are able to find for this column, if we are able to find all the 3 operations around it, because our answer is based on these 3 columns, this column, this column, and this column, this column, this column, and this column, and this column. These are the same operations, right? So if we are able to find all the 3 answers, and we are, because this represents base case, and base case we already know, right? Base case we already know that this is str2.length minus j. Okay, str1.length minus j. If they are empty, we have to do this. Okay, so let me just do this, do that as well. So let's say there would have been this string. Okay, this is the thing. Okay, we have to fill these columns now. Okay, when I is equal to str1.length, so I represent this, so I is equal to str1.length. Okay, this is was the base case, right? If you remember, and j is equal to str2.length. J is equal to str2.length. Okay, so now what we actually have to do, is we have to go on each column one by one. Okay, and we have to fill some values here, so that for this column we have all these 3 values, right? And how we are going to fill that? So let's say this would have been ABC, this is AXC. Okay, now what will actually happen is when we are here, the answer will be 0, that both are empty. Okay, now we move forward. When we move up, there is only C here. Okay, there is only C here, and this is still empty. Okay, so let's say in one string we have C and other string is empty. So we have to insert this C in another string. So the answer will be 1 only. So here the answer will be 1. Okay, now we move forward. So here we have XC and this string is empty. Second string is empty, and here we have empty string, and here we have XC. So if one string has XC and one string is empty, so we have to insert XC into the other string. So the answer will be 2. Okay, same way if we have AXC and empty string, the answer will be 3. Okay, same way here, if we have this first string empty, so here if we have C only, so the answer will be 1, here it will be 2, and here it will be 3. This is how we have to fill it. Okay, and how we are going to fill it is that every column represents, actually, if we are filling this part, and we start from here, we are just going to fill it like whatever is the length right now. Okay, whatever is the length right now other string, we are going to fill it that. So if let's say this is str, okay, so a little confusing, so 0, and here it will be 1, here it will be 2, here it will be 3. Okay, so as we go up, we have to fill the distance, right? So let me write the code, and then I will show you how I am writing it. So but the case will be this only, 0, 1, 2, 3, and 0, 1, 2, 3 in these columns. These are actually representing the base case, and then we can start from here because we have answer of all 3 columns. Okay, all 3 columns. So let me write these, let me fill those columns. So for So for int I equal to 0, I less than not 0, we have to start from the last column. So str1 dot length minus 1, we are going to start from here, right? I should be greater than or equal to 0, I minus, right? We are going to start not str dot length minus 1, we are going to start from str dot length. Okay, we are going to start from there and we are going to fill them. So dp of str1 dot length is I, right? So we have to start from str2 dot length. Okay, sorry, we have to fill this part, column j equal to let's see if this will fill it or not. Let's see what I have written here. So dp gone fat, and also instead of doing this, let's n is equal to str1 dot length. Let's do this and int m is equal to str2 dot length. Okay, let's fill that. So we'll start from n and we'll go for to here and here as well. I'll go for n and I. Okay, so let's see if I have written the correct code. So let's see that. So what I am doing is I'm starting from n. N means str1 dot length. That means I'll start from here. str1 dot length. I'll start from here, and what I'm going to do here is I'm going to start from here. I'll go till 0, greater than or equal to 0. I'll go here, this part from 0 to this, and what I'm doing is dp of I is dp of n. That means dp of nm. Right now I'm here, dp of nm, and what I'm going to do is I'm going to put n minus I there. So n minus n there, so it will be 0. That is correct. Then it will move back, so it will be I will be subtracted, so this will become I minus 1. I was n initially, then it will become n minus 1. N minus 1 means str1 dot length minus 1. That means this, right? str1 dot length minus 1, that means this. So only rows are changing, right? So it will be n minus I. It will be n minus I. N right now is let's say n is 4, n is 3. 3 minus I will be n 3 minus 1. So 3 minus, okay, got it. So it will be 1, it will be 2, and it will be 3. Yeah, got it. So it is correct. It is correct. So we have to fill these values like this, right? And same way we have to fill these values as well. We have to fill these as values as well. So that way, as that is also we are going to do the same way. So for int j is equal to m, we are going to start from m, and I should be greater than or equal to 0, and I minus minus. So we are taking j here, so let's say j here and j minus minus, and what we have to actually do is we have to make dp of n and j. dp of n j is equal to m minus I. Okay, so you just have to think that how you can fill these columns, right? This is just to fill these columns, right? These and this. So just a little bit of confusion here. Not confusion, you just have to think how you can write it. You have to just go on the columns and rows, and you have to do that, right? So these are the two cases that we have to do. Okay, this is what we have to do, and this will actually fill these last columns and rows, this last column and row with the values 0, 1, 2, 3 and 0, 1, 2, 3. Okay, these will be filled with these, right? This is the case. Now this is done. Now we are done with this. So now we just have to return our answer at dp00. Return dp of 0 and 0. Okay, this is what we have to do. Return dp of 0, 0, and this is done. Min distance dp, let's try to find out. Okay, here we just have to remove this. Before the answer was 2, here as well the answer should be 2. The answer is 1, so there is some problem. So let's see that. Hmm. Min distance I am calling, or min distance dp. See, exactly this is the thing that I have done. Okay, str1 dot length minus I. So str1 dot length minus I, and here str2 dot length minus j. So exactly the base case is also same. str2 dot length minus j. Okay, base case is also same. This is the exact thing. If you can write the recursive code, you can directly write the dp code as well. Okay, it will be n minus I, it will be n minus j. So just I have to think that why it is not giving the correct answer. If I have done some mistake. N minus 0. So first of all, let's say ax abc axc. Okay, so let's see, these are the two cases. Here just have to fill 0, right? So I start from n and go till greater than equal to 0, I minus minus dp of I, that means dp of nm, that means this dp of nm will become n minus I is n minus n, it will be 0. Same way here, dp of nm will become m minus m, it will be 0, so it will remain 0. Okay, now we move up, so I will become n minus 1, that will be, let's say it is 3, so it is now dp of 2 and m is the last thing, let's say 3, 2 3, so 2 and 3, this is the case. So here we have to fill n minus I is n minus 1, I is 2, right? So here I will fill 1, so it will be filled like this only, this is correct. Now let's see this part as well. So it will be dp of n, dp of 3, which is fixed, and j, it will be j, so j is also 3, so it will be 0, so then j will be decreased, right? J will be decreased, j will become 2 3 2, so it will be 3 2. Okay, start from 3 2, so here we have to fill m minus j, m minus j is, it would have been 3, then it will become 2, so m minus j is 2, that will be 1, then 2 and then 3. This is okay. Now let's see the process that we are doing, if that is correct or not. If that is correct or not, this is exactly what, sorry, this is exactly what I needed, but the main thing is we have to see this, right? So now let's see if we are working fine or not. So here what I will do is, I will see if the characters are equal, then I have to do this, otherwise I have to do this part. Okay, so if they are equal, so sorry, axc, they are equal exactly, axc, so they are equal, so what we have to do is simply do nothing. Okay, I'll just, whatever the answer is here, the answer will be 0. Now I'll move here, if they are equal, b and c, no they are not, so I have to take the minimum of all three, which will be 0 plus 1, so it will be 1, right? Now here a and c, they are equal or not, let me put it here so that everyone can see, right? So here you can see that we have to take the a and c, so a and c are not equal, again minimum of all three, 1 plus 1, answer will be 2. So I'll come here then, so here as well, if they are equal, c and x not equal, minimum of all three 0 plus 1, answer will be 1. Here as well, not equal, minimum will be 0 plus 1, answer will be 1. Here as well, minimum of all three, because they are not equal, x and a, so 1 plus 1 2, the answer will be 2. So let's come here now. So here a and c not equal, minimum of all three 1 plus 1, answer will be 2. Here a and b are not equal, so minimum of all three plus 1, answer will be 2. Here they are equal, so we have to just take whatever the answer here is. Okay, this is the case. So here the answer should be whatever, if we are taking from here, so answer is 1, so but the answer should be 2, right? So where I am getting it wrong here, so here if I start from here, the answer should be 0 because they are not equal, but when I reach here, okay, according to this case the answer should be this only, but it should change because here we have this, minimum of all three will be 0, minimum of all three will be 0. As they are equal, so we just have to put this, they are not equal, somewhere there is a mistake, ABCEXC. I'm writing it for ABCEXC. Okay, ABCEXC. Let's try it for this. 0. So 1, there is some mistake in some of the answers. They are equal. It should be 1 actually, because we have done it for that ABC and AXC. So for this ABC AXC, there is some issue of 1. Okay, so let's see that. It should be from n to 0, minus minus j minus minus. It should be m minus j. I think this is correct. Anything else I'm missing here? The way I have done it, it should be 1 only, and the answer should be 1 for this ABCXC. That we just have to replace x with b. That should be the case. But some mistake in code. The logic is correct, but there is some mistake in code. So what is the mistake I have done? I plus 1 j plus 1 I plus 1 j I j plus 1 return I plus 1 j plus 1. That is okay. So here, starting from this to this, here as well, n minus I j minus j, everything seems correct. Plus n to 0 m to 0, right? I m n j. There is some issue there. Let's debug it. So while starting from here, first of all I'll check if they are equal or not. Okay. That means this is not filled correctly, most probably. So let's try run this. Starting from n, it will be dp of nm. Okay, dp of nm. So dp of nm is this. That will be n minus n. That will be 0. Okay. Then dp of n minus 1m. N minus 1 is, let's say this is 3. So 3 minus 1 is, it will be dp of 2 and m. M is 3. 2, 3. So 2, 3 will be n is 3, like 3 minus I is 2, so it will be 1. So dp of 2, 3 will be 1. So we'll again go there. So it will be 1 again. So dp of 1, 3. dp of 1, 3 will be 3 minus 1, which will be 2. So it will be 2, it will be 3. Same way here, if we have m and it is greater than equal to 0, j minus minus, so it will be dp of n will be fixed, and j will keep on changing, and it will be m minus j. M minus j. Things are correct, absolutely correct. Logic is absolutely correct. Where is the issue? What's the issue? That will not work. ABC, AX. So I have taken ABC on this. So let's try that as well. ABC, AX. So should be same actually. That won't work. So let's just see once again. I don't think there is any issue in this. So let's just take one thing. We can do one thing here. So let's see for dp of 0, 0. Minus j and minus I. Okay, so one thing we can do is we can directly see something here if we can find it. Okay, this is a different level, like this is a top-down approach, not the one we are doing. So we cannot find anything here because this is a top-down approach. And for that, Anything has to be done more specifically. So most of the people just do the top down and not the top down approach. They actually do the bottom up, like top down approach mostly. But let's try to do something else. Dry run is also working correct. So I don't know where the problem is. So let's try it again last time. So here it would have been from n to 0. Okay, n to 0 we have to start from there. We will start from here. It will be 0, it will be 1, it will be 2, it will be 3. Right, same thing we will do here. I'll start from here. It will be n minus n0, then m minus 1 will be 1, so it will be 1, then 2, and then 3. Right, so what we can do is, yes, one thing we can do is, if we can print this whole DP array. Okay, so whatever is the DP array we are getting, let's print it. Then we will get the correct answer where we are actually for. Okay, so let's do that. So for int I equal to 0, I less than n, less than equal to n, I plus plus. Okay, and for int j equal to 0, j less than equal to m, j plus plus. Okay, and what we have to do is we have to print it. Okay, system dot out, let's print the whole DP array that we have made. That way we will find the answer, I and j. Okay, and then we will have a system dot out dot print. Okay, so let's run it now. We'll get the answer, and here let's print ln here as well. What happened? Where is it? Minimum distance dp. Okay. Okay, got it. Sorry. Here we have to fill the value dp of ij. That's why it was returning from there only. That was the issue. We have to fill the value. We don't have to return it. We are not filling the DP array. That's why it was not giving the correct answer. I and j. Sorry. Because we have copied it from the recursion part. That's why it was giving the error. Okay. So now let's try it. Now you can see the answer is 1. The answer is correct, and this is our DP array. Exactly the one that we made. Right. This is the exact. Okay, so this would wasted a lot of time. We just don't have to return it. We have to fill the DP array. Okay, because I tried to copy it from the recursive code, that's why it was left return only. So now this is the thing we have to do. 1 2 2 3. So this was the array, right? If you remember, this was the exact array that we have made as well, like exact DP array. So now the answer is 1, which is correct. We can try this code on LeetCode as well. Let's try to submit it on LeetCode so that we know, right? I'll remove this part. So let's remove this return part and print part, and let's try to submit it. Control C, control. And here this is word 1, so I'll change it to str1, here also str2. Okay, so now let's try to run it. Here we are getting the correct answer. Answer is 3. So now let's try to submit it. So you can see the answer is correct. It is more than 74%, and it is a good one, right? So first time I have submitted it, so that is fine. Okay, so this is the correct one we are doing. Okay, so I hope you have got it, how you have to solve the question, any DP question. Just if when you are copying the code, just think of it this way, that we don't have to return, right? We don't have to return, we have to actually give the DP array, DPIJ. We have to fill the array. Okay, if I just wrote return here, that was a problem. Okay, so I hope you guys have got it, what we are doing here. Okay, just try to do it by yourself as well. These two questions are very important, like interview preparation questions these are, and these are very important, right? So just try to do these two again, just revise it, and we will meet tomorrow again. We will do knapsack problem, right, and question related to that, like we will do knapsack and coin change tomorrow. Okay, these are the two questions we will do tomorrow. These two questions were also very important. Just do it again, and also join our Telegram channel if you haven't yet. And also thank you very much for joining in. Just go like, share and subscribe. This is very important. Okay, so bye bye.